Hi everybody, my name is Quoc-Anh and my partner is Nguyen from the Information Technology Institute, Vietnam National University. For ICACT 2022, we are here to present our work. A fast clustering-based recommender system for big data.
Today, I will introduce to you 5 parts. 1. Introduction and motivation. 2. Our objectives. 3. Our proposal. 4. Experimental results. And 5. Conclusion and future work.
So, we start with the first question. What is a recommendation system? A recommendation system uses the data collected from users' behaviors to predict and suggest products, features, and services they may like. Nowadays, they are a significant integral part of most modern systems. For example, in many e-commerce platforms like Amazon, eBay, Lazada, or Vietnamese companies such as Tiki, Mobile World Investment Corporation, to mention but a few. Users will receive personalized suggestions from recommendation system based on their previous choices and interests. It is worth saying that recommendations is the key to the success of any e-commerce platform. With the development of e-commerce system, the recommendation system is now an essential part of the success of that platform. Recommendation systems are generally classified into 3 main categories. 1. Collaborative filter, 2. Content-based approach, and 3. Hybrid approach. The content-based filter provides buying and selling recommendations to users based on product-related content. The collaborative filtering uses the interaction in shopping behavior between customers to determine a customer's preference for a product. Nowadays, rapid progression in technology and increasing use of online interactions have posed new challenges for current recommendation systems. One of them is data explosion.
Data explosion, as we often naming technically, is big data. Big data is characterized in 4 V's: volume, variety, velocity, veracity. The exponential increase in the volumes of e-commerce data is real, and it poses challenges in managing and utilizing this data, and leads to another big question: how to leverage big data in making recommendations. This is our motivation.
To be clear, 2 our main objectives are as follows. Firstly, explore some current big data frameworks. Establish a suitable model that can be effectively adapted to store and manage large-scale datasets. Secondly, propose a fast clustering-based recommendations method we can design on top of Apache Spark. In the next part, I will present our proposal, the implementation steps, the evaluation method that we used.
Our proposal is done through 3 steps: clustering, calculate the value of importance, and rating prediction. Given a training set as the user item interaction matrix R, our proposed method starts with the clustering process. The set of users will be divided into different clusters. To do so, we establish a user feature preference for each user. Assume that the category of an item is known. In case of MovieLand's dataset, the genre of movie is among 19 different categories. The user preference according to their preference of movie genre is introduced in definition 1. Once the set of clusters is given, we implemented step 2. For each user, we establish the importance within the clusters as shown in definition 2. And next is step 3. By equation 5, the rating prediction can be made directly according to their preference and significance in the cluster.
And this is definition 1, definition 2, and equation 5 for you to see. 2 well-known metrics for evaluating the performance accuracy are mean absolute error, MAE, and root mean square error, RMSE. Both metrics are ranges from 0 to infinity, and the lower error value indicates a better recommendations accuracy. However, The difference is that in MAE, the errors scale linearly, while in RMSE, the errors are square, meaning that RMSE gives relatively high weight to laggard erosion. In our proposal, we use dataset is movie length. Movie length is one of the most popular datasets widely used in education, research, and industry. It was collected by Copeland's research group and can be considered as a standard dataset in the domain of movie recommender system.
It can be observed that the data sparsity and item code start problem occur in this dataset. First, a high level of sparsity indicates that most values in the rating matrix are unknown. The sparsity level of movie length 100K is 93.695%. It could result in impediments to practical recommendations. Second, the distribution of movie ratings depicted in Figure 2 reveals the fact that the bulk of movies are relatively unpopular with only few ratings provided, leads to issue of item code start. Our system is built with the data layer and the application layer that are connected via API drivers. The dataset is written to HDFS. Then for each task, appropriate data is loaded in a distributed way into RDDs and transformed to be analyzed using Spark. We developed the data layer containing 3 nodes, 1 for Spark masters and 2 for Spark workers. Recommendation method is implemented and run in the Spark cluster mode. In the software configures, we use Spark 3.1.2 Hadoop.
Let's move on to the part 4. Here we described our experiments and their results. In the first experiment, we implemented 2 recommendation algorithms, user-based collaborative filtering, user-CF, which is a collaborative filtering method based on user-adjusted cosine similarity illustrated in algorithm 2, and our proposed method denoted as FCR. Besides normal cases, we validate the effectiveness of our proposed method in addressing the item cold start problem. This problem appears when new items arrive with no or very few interactions. All results obtained in the normal case and new item cold start case are depicted in Table 4.
Obviously, from the obtained results, it can be seen that our method addresses the problem of item cold start effectively, 4.46% less error than the traditional user CF method. Besides, the training time is 3 times faster and the average inference time is almost 133 times faster than user CF as a consequence of the fact that the rating is predicted in a constant time. Nevertheless, as a trade-off for a fast execution time, when we evaluate our recommendation method in 2 prediction accuracy metrics, MAE and RMSE on the whole testing set, their values increased slightly, 3% larger, compared to those of user CF.
Secondly, in terms of only MAE and RMSE, we also compared some of those public methods in the literature that solved the close issues and experimented on the same dataset as summarized in Table 5. The results of RBRA, BIFU, and RNCF are presented according to the original papers. Our method, FCR, is proven better than RBRA in 2012 and BIFU in 2014, although it is worse than the RNCF algorithm in 2020. To sum up, the work has explored some current big data frameworks, then built suitable components to effectively store and manage dataset in big data environment. In the work, we also proposed a fast clustering-based recommendation method addressing data sparsity and the item cold start problem. The method was designed on top of Apache Spark. The experimental results showed that the training and inference time of the method is speedy, while the slight increase MAE and RMSE is acceptable. However, the limitation of the work is the experimental dataset is somewhat small. In our future work, experiments on larger datasets will be conducted. Besides, we expect a design of new clustering-based methods by exploiting the properties of matrix factorization approaches. That's the end of our presentation. Thank you all for your attention. If you have any question, it's my pleasure to answer.